Well, hey, you guys, I know this recording looks a little weird because I'm off to the side because I'm going to use this chart paper as a whiteboard as I teach. So imagine that you're sitting in class with me and listening to me as I visit with you. Probably throughout this recording, you're going to need to pause the video and then take some notes and then come back to it. So here we go. So what I had you do today was to carry out an investigation. And in fact, the video that you just looked at was called Planning and Carrying Out an Investigation. And that's what you guys did. So I don't need to write this all down, but you know what I'm saying, okay? Carrying out an investigation. I had you choose 4 heights between 0 and 100 centimeters and then drop the ball from those heights and record the bounce. As you did that, there were factors that played into whether or not the data that you collected was would result in logical conclusions. Remember from our discussion earlier about an experiment, we said that experiments are repeatable and they also help us to draw logical conclusions. In order for something to be repeatable, we have to take care of any of those factors that might affect the outcome. Those factors, if I had you in class and I asked you these questions, you would be able to tell me what some of those factors are. The big heading or the name for those factors are what we call variables. They are things, factors that will affect or vary the results that we get. Things like this. Let's say you were dropping the ball from 80 centimeters. So on the meter stick, this line right here represents 80 centimeters. Well, I've got the ball, and the question is, what about the ball if it's the middle of the ball is right at the 80? Okay? What if I dropped it from there, but then when it bounced up, I measured the height of the bounce at the top of the ball? That's different, isn't it? That could change my results. It's a different factor. What if the bottom of the ball was on the 80? Or what if the top of the ball was on the 80? That becomes a variable. I'm going to come back to that in a minute. What about, so that's where you dropped it from. What about where you measured the height of the bounce? As I said down here, did you measure it at the top, in the middle, or at the bottom? What about how you dropped it? Did you hold it on top? Did you hold it on the side? Was there any interference? Did it bounce off the meter stick? Did it bounce off the wall? That would be a factor that would affect our results. So all of these factors are called variables, and what we want to do in any investigation is to limit our variables. Now, when we limit variables, the other term for that is called to control our variables. We always want to identify what those variables are, and we always want to control them. Now, there is nothing magical about dropping the ball from the middle. So if it's 80 centimeters right here, if we line up the middle of the ball, that's great. As long as you do it the same way every time. That's what controlling our variables means. The same way every time we do something. That would even go so far as to say the same person should drop it the same way every time. That's controlling our variables. Okay? So hopefully that begins to make sense. And again, this is all under that heading of planning and carrying out an investigation. You created a data table. On that data table, you have the height of a drop and you have the height of a bounce. Those are our 2 experimental variables. This is the data that we've collected. We know that we collected those in the units of centimeters. We always include the units so that we don't have what we call naked numbers. The number 27 just sitting out there means absolutely nothing. It has to have some unit with it, like 27 years, or 27 centimeters, or 27 decades. Each one of those is different. The number 27 is different because of the units that come after it. So we never have any naked numbers. The question to you now is you should be able to answer this question. which of these, the height of the drop or the height of the bounce, is our independent variable, our independent experimental variable. And once you've identified the independent, you automatically know which one is the dependent. The other term for independent is manipulated. In other words, which one did we manipulate, and then which one responded to what we manipulated. Another way to ask that question is, which one of these did we have control over? In other words, we decided that we were going to drop it from a certain height, or did we decide we were going to let it bounce to a certain height? Well, obviously by now you say quit talking, because the answer is the height of the drop. When we build our graph then, we have the y-axis and we have the x-axis. The independent variable always goes on which axis? Yes, the x. It goes down here. So this is the height of the drop, right here. And when we label this, we'll write height of drop, and then we'll put the units underneath it so we don't have naked numbers. That's centimeters. And then over here we would write height of the bounce. And again, we would say that that was in centimeters. We know that this point right here is the 0, 0 point. Graphs actually continue both directions. This becomes negative numbers here. These become negative numbers down here. Okay? But we can't drop a ball from a negative height, and it can't bounce to a negative height, so we ignore this part of the graph. So we only have this quadrant of the graph that we're working on. You know that your height is somewhere between 0 centimeters and 100 centimeters, because those were the parameters that I gave you. You also know that your bounce was somewhere between 0 centimeters and whatever. Maybe it only went up to 75, so you could make this one a little bit longer. What you need to do now is count the number of lines that you've got to figure out what distance you're going to use between each line. Now, I don't have very many lines on here, so I'd have to go by 10. So that would be 10, 20, 30, 40, 50, 60, 70, 80, 90, and man was I good, because there's 100. One of the things you can sometimes do too, let's just do the same thing up the side, is I can skip a number. So I know this one's 0, that one's 10, this one's 20, that one's 30, that one's 40. I don't have to label absolutely everything. I can do it this way too. Okay, now we've got a data table, which I didn't put up here, but you've got the height of the drop and the height of the bounce. You've got your averages, so you're only going to graph the averages. So let's just say I dropped it from 20 and it went up somewhere about right here. Okay, let's put a dot on the line. I dropped it from 50 and it bounced up somewhere to about 35 or somewhere right in there. And then I dropped it from 100 and it bounced up somewhere like right in through, let's say there. Okay? Now let's do a couple more. Let's just say I dropped it from 70 and it went there, and I dropped it from 40 and it went about right there. Okay? Now I've got at this point what's called a scatter plot, because I've got scattered dots on a plot. I now ask myself two questions about the data that I see in front of me. Because what I want to do is I want to create or draw what's called a line of best fit. In other words, what line best fits the data as we see it right here? When I draw a line of best fit, I'm really looking for one of two lines. I'm going to draw this over here, and hopefully you can see this side. You either want a straight line or you want a smooth curved line. In most cases, we do not draw a dot-to-dot line. In other words, we don't go from here to here to here to here. We do not draw a line that looks like this. Okay? We draw one that either has a straight line or it has a smooth curve to it. All right, so back to this. We've got a dot here, got one here, got one here, here, and here. Now the question is, does it basically look like that's a smooth curved line, or does it basically look like that is a straight line? Since you're not here, I heard everybody say that it is a straight line. Well, it actually is, and what I'm going to do now is I'm going to draw a straight line, but I noticed that not every one of my dots lines up along the line that I'm going to draw. So I want to have about an equal number of dots above my straight line and below my straight line. So if I have a ruler or something, I could use that to make sure that I get a perfectly straight line. So I'm going to reach over here and get a box. Use the edge of that. So I'm going to say that my line is somewhere about right through here. And run it all the way down here, okay? And you'll notice I've got this dot almost on the line. This one's right at the line. This would continue on up. This one's a little bit below. This one's a little bit above. And that one's a little bit below. So I'm probably pretty close to what I call my line of best fit. Now, what the cool thing with this graph is I can use this graph to predict other heights of drops and heights of bounces, even though I haven't measured them. So for example, let's say I want to predict how high the ball would bounce if I dropped it from 60 centimeters. So I go across the bottom, height of bounce is 60, I go up the 60 line until I hit this graph, this line right here, and then I come to the left, it's about right here. Well, I know that's 40, I know that's 50, so I'm going to say if I drop it from 60 centimeters, my prediction is it's going to bounce up to about 49. Do the same thing, say it's 80. I would go up until I hit the line, I'd come across, and it's about 70, okay? Just so you know, this is not actual data. I made this stuff up. But you can see how you can predict using a line of best fit. So what I'd like you to do is graph your data. You graph your height of the drop against the average of the height of the bounce. And then I would like you to choose 4 other heights of drops that you don't have dots for and predict what those height of bounces would be. When you come to class next week, we'll actually get the materials out, the same materials that you used this week. I'll send you back into the restroom and you get a really quick opportunity to test your predictions and to see how close your predictions were. Okay, so that's it. Draw those graphs, make those predictions, make sure you have notes over all of this, and I'll see you next week. Bye-bye.